The current Linux desktop landscape is very complex and variegated. This is a known fact about the Linux ecosystem as a whole. Unlike commercial desktop alternatives, you do not just get one target. There exist many desktop environments, at least many software distributions, and if that wasn't enough, there's also several different ways to install applications. The last point is the most crucial part. Long gone are the days where the only way to install an application on a Linux system was through the distribution package manager. Nowadays, sandboxed environments are the norm. It has gotten a lot more common to install applications using a containerized environments such as Flatpaks or Snaps, and as we know, this approach gives us a lot actually of benefits, the most important being the ability to compile an application against one single runtime and be sure that it works on like any Linux system that it is thrown at, no matter how the system is configured or how old the package are shipped. It would be natural to ask ourselves, how do applications manage to work so well across such a diverse range of configurations? And the answer partially is thanks to free desktop portals. So a Portal is probably one of the most memorable PC game franchises to ever have existed. Developed by Valve, it consists of two titles, Portal and Portal 2. Where the player is tasked with completing a sequence of test chambers by completing increasingly intricate puzzles, and while the puzzles themselves can prove pretty hard-scratching, the rules of the games are quite simple, and the main part of how they are solved revolves around using your portal gun to shoot two interconnected portals around the chambers and using them at their best to interact with the rest of the world. The solutions to these puzzles are often quite crafty and it's fun to go through them. However, being able to clear these challenges solely depends on abandoning your usual intuition on how you'd solve a problem. There's a point that I'm trying to make, I promise. And instead thinking about how portals could be useful to you in that situation. In the Portal community, we call this mindset shift thinking with portals. It's hard at first, but everything makes sense once you start thinking with portals. Linux desktop application development sort of hinges on the same concept. First, let's make it simple. Imagine a running process associated with an application that seeks to record your screen. The peculiarity of an application like this... Okay, so as a bit of context, let's stop this. As a bit of context, I have other people that help me write things, and this is one of the instances where I did not proofread the script. So the angle that Luca chose to write this article is pretty funny. Can we get back to the script that I was reading? I was saying, the peculiarity of an application like this is that it does not exist on its own. It needs to consume a resource to do its job. In this case, it needs to access a stream of what is happening on your monitor, then save its state for several times a second, then stitch all those screen captures together into a smooth video. This is Unix, so let us suppose that you could probe a file to do this. This would be clearly problematic. Firstly, if this was possible, it would be a giant security flaw. Imagine any process running unprivileged was able to look at your screen. It would be extremely simple to make spyware go unnoticed. Secondly, it would not work on all configurations. GNOME's Macro Compositor would handle its monitor output one way, and Katie's Kwin would also do it another way. WLRoots would choose a different way entirely. Plus, how would you go about accessing it through a sandbox that likely shields your process from poking around with files that are outside its own private directory? This is why it's necessary to come up with some kind of standard. Applications need a standardized way to talk to each other, to share resources, send each other messages, and do what they need to do, complying to that standard. This need is fulfilled by DBus, the most basic layer of the architecture which we are looking at today. In any software system, different components usually require a shared pipeline to talk to each other. The broader topic of processes talking to each other is called IPC, which stands for Interprocess Communication. There are several IPC interfaces available, all with their pros and cons, shared memory, mailboxes, message queues, message buses. When you're dealing with complex architectures made up of several components that might all need to interact with one another in ways so complex that it is pointless to try to restrain that communication to a predefined route, one of the best bets that you have is to use message bus. Every IPC interface can be thought of as something physical, let's say. You can think of a message bus as a bulletin board. It's placed in a public location and anyone can attach post-it notes to that or read existing post-its. And a message bus shares the same idea. Students who go read the bulletin board are the processes that subscribe to that bulletin board, while the landlords advertising their laughably above market rate double rooms located right in the middle of nowhere are the processes that send messages to the bus. This way, a process can put up a post-it, a message that other processes who are looking at that board subscribing to the bus can read. Well, dbus is the standardized message bus that applications, compositor entities on Linux use to talk to each other. If you're curious knowing how a message bus works, you can go ahead and see everything that is going on here. You can even get a pretty graphical overview of it using something like Basto. So finally, what's a portal? Before that, let me tell you about the sponsor of this video, which is no one, or rather it's you. In order to do all of this, I have to pay not only hosting costs and fees and taxes, but I also pay for other script writers such as Luca, who wrote this script, and equipment to do all of this. Sadly, this currently puts us as a loss of like $500 a month or something like that. In order to continue making these videos, I need to break even. There's almost 100 people already supporting me amongst various platforms, Patreon, PayPal, LibraPay, and Ko-Fi, and I'm extremely grateful to all of them, as that's the only reason that I'm able to do all of this. Links are in the video description if you want to join. Finally, you can also subscribe on the website thelibre.news. On the same website, by the way, you can read this video as a text article if you prefer reading over watching videos. You can also subscribe to them to receive them as newsletter if you prefer. There's also extra content for subscribers like interviews and team meetings. Just a couple of them right now, but anyway, back to the video. To put it simply, a XDG desktop portal is an interface that an application, be inside a sandboxed environment such as Flatpak or running natively, interacts with the surrounding context to obtain resources, request permissions, and overall interact with the system. As the project description suggests, the XDG desktop portal exposes a series of dbus interfaces accessible under the standardized name of org.freedesktop.portal.desktop. Those interfaces expose several APIs that regulate the interaction with various resources, and each of those interfaces is a portal. Portals are especially useful when an application runs sandboxed, because they act as a portal to interact with something that is inside of the sandbox. It makes intuitive sense. In Portal, use portals to break out of undesirable situations. On the Linux desktop, use them to access something that is outside of the sandboxed content. However, it is crucial to understand that portals are not exclusive to sandboxed environments. They expose standardized APIs, which means that you as a developer must not worry about the differences between desktop environments, Windows systems, or how the application is executed. If you use portals, you can rest assured your application will just work everywhere. However, your users will decide to install it. And if you need to ensure that it will run predictably on any distro, regardless of what versions your dependencies and installation bundles, you just add Flatpak in the mix. Different portals expose different resources, and each desktop environment is tasked with implementing each portal. The challenge here is that for the more niche portals, it is not guaranteed that every desktop environment has a working implementation for every single portal. Sadly, this is as good as it gets. If a desktop environment does not support X, then X will not work at all on that desktop. There are portals for several use cases, and more keep getting added. As an example, the camera portal regulates access to your webcam. The documents portal allows a sandboxed application to access a single file of your choosing without needing to have access to an entire directory. The file chooser portal will use the correct file picker dialog for your current desktop environment. The game mode portal allows a game to let your desktop environments know when it is running, typically suspending non-essential background tasks like automatic updates while the game is running, to avoid having to slow down the game by allocating those other things resources. Portals also allow implementing a permission system for the most crucial permissions. As an example, the dialog you get when you try to share or record your screen with something like OBS or Discord is part of the screencast portal. Free desktop portals are the unsung heroes of Linux desktop, and this beautiful plurality of desktop environments and packaging formats wouldn't exist without them. Portals are also evolving. Expect new portals to expose even more functionality coming to a box near you. Okay, that was pretty funny.